Hello friends, and a very good morning to all of you. Yeah, in my last video I solved some get questions, organic chemistry questions, and I was in somewhat rush, so I couldn't explain one example well. So I'm taking this example again, and I have another 9-10 questions. I guess total I'm 11 questions solving in this session, which were asked in GATE, which was held yesterday. Okay, so here we go with the question. You have NO80, which is a base, and it needs a one acidic proton, so it takes from this thing. And as I told you in the last video, here you are getting this kind of intermediate. So here is CH2 will attack one of the carbonyl, which will become OH, let's say, and then one more carbonyl, OET, and here is your NO2. With this, they are giving you zinc and acetic acid, which is very much simple and very much famous a method to form one heterocyclic compound, popular heterocyclic compound for all the medicinal chemists is being formed here. Sorry, it's a 5-membered ring, guys. Here is NH, which is nothing but the indole, and this kind of a substituted indole you are getting in this case. So this is what your product. Okay, so now next we have one more simple example. I got today new questions, and so immediately I'm bringing them to you. Yeah, this is a very simple case where your zinc incorporates between C and Br, which makes this as an anion, and that would attack now on the carbonyl of your benzaldehyde, forming, let's say this is benzene from benzaldehyde, and then you are getting, sorry, it has been somewhat crossed. Okay, so you have OZN. Zn means it's O minus, and zinc is a counter ion for it, and then the carbon, then double bond to the next carbon, yeah, then one more carbon, and then CO2, and then this cyclazes to give you such a kind of a product. So finally this would be your answer. pH means this benzene ring. Okay, then there was one more example. One dienone type of a system was given, and it has been treated with a H plus. This is a special kind of a rearrangement which is given in Claddon. I think it's dienone to phenol rearrangement, and aromatization takes place. Phenol, sorry, it's a single bond, and then the methyl group gets shifted over the aromatic ring. So this is what is rearrangement. You can search it in the Claddon. You can get it in the Claddon. Then the next question was from organolithium chemistry, and let me tell you, the maximum parts of the question, maximum questions in yesterday's exam were asked from the Claddon, and few of those were picked from the Caruthers. Out of these, this example is from the Caruthers one, and rest of were from Claddon. So this is a kind of organolithium compound where this has to be an ion, and then that will go to your electrophilic center, and finally you are getting such a case. This is what your product. Then the next question was very much easy. This I think is 12th level question. Yeah, they asked you, they giving you one alpha bromo acid, and at the one condition there was silver oxide in NaOH and H2O, and other condition there was only NaOH and H2O. And they were option key, right? In both cases the stereochemistry gets inverted, or one retain and one inversion. So how it goes, basically, if you start with NaOH, if OH minus would attack, this goes in SN2 fashion, because if you detach the bromine first, and if you'll make carbocation there, it's not that much stable, just because of carbonyl CO, which is a electron withdrawing group. So it has to be go through a SN2 mechanism. That means OH has to come from the backside of the bromine, and hence in this case you are getting inversion. That means if it's written that A and B, then A product will be inverted, and in case of a Ag2O, the silver salt is being formed. Silver salt of your carboxylic acid is being formed, and there the oxygen, lone pairs of oxygen, takes part in neighboring group, and because of the NGP you are getting the retained product. Okay, so B is what? Retention. Then that was the easiest one. Then there was one interesting question, not that much easy, but it was interesting. Okay, you had a system, carbonyl system with KOH, ETOH, and here you can see at both there is only one acidic proton. You can see at the other hand it becomes so much cloudy. So here your enolate has to be formed. Okay, and then this enolate will attack on this carbon in the 1,4 fashion to give you the product. Like I'll write the structure of P, 6-membered ring with so this is next part coming from this compound and carbonyl of the original and this kind of a product. Then you are given with HCl. Here a special kind of a reaction takes place, which is a Robinson annulation. I solved one question in my I think the last video which I updated in uploaded in 2-3 weeks before. You can go and check there. So you are getting this kind of thing. There I explained the mechanism of Robinson annulation also. So this is the product, and you might be not getting any of the options matching to this product. But what happens, you have HCl, so another molecule of HCl comes here and now will now protonate this one, and as being H2O plus, it gets off, and here is a plus. And here the special kind of a rearrangement takes place due to the strain of this ring and the stability of this tertiary cation. The bond breaks, one methyl group shifts here, and finally what you are getting is sorry no, methyl group doesn't shift, the proton goes here, because if the double bond becomes, if the double bond is getting formed here, it will be a conjugated system. And so see, you're getting this kind of an intermediate one more. Okay, because this thing, this tertiary cation is going to be very much stable, and then your coming Cl minus would go on there. So finally the final product would be sorry, I'll write it on the next paper, because yeah, so finally you would be getting double bond O, then okay, and what we have one methyl over here, and this is the Cl. So this is going to be your final product. Now I have more questions. Okay, so there was one more question ki alpha D glucose if treated with acetone in excess, then this is a basic level question of the glucose chemistry production, just the protection of carbonyls alcohols of the in the glucose molecule. So this was the product there. Then there was one question which where you were given with NMR values, H1 NMR values, and from these values we were supposed to predict the product, predict the structure of the compound. So this is the structure of compound where the carbonyl frequency was given, I think 720 or something. IR frequency was given, which has to be of carbonyl, and then there were 5 protons which were indicating that the protons were has to be from aromatic ring, hence the aromatic ring has to be monosubstituted, and there was one value which was 4.23 something for the 2 protons, and those 2 protons were triplet, and then moreover there were 2 protons which showed sextet. So these 2 value would decide exactly the product, because there were some other options which wouldn't match these 2 values, and yeah, of course the others are affecting, but these 2 values are the main reason and the strong proof for this structure. Yeah, then there were some sets given, and out of those you have to find out some sets of diastereomers. So according to me, according to my knowledge, there were 4 sets of diastereomers. Then there was one more question, you have to find out the stereochemistry of 2 centers, which were nominated as I think 4A and 8A. Now exactly I don't remember what was the stereochemistry of which thing, but there was something like this system, I guess. A bicyclic compound was there. One had, yeah, OH, and one had this one. This was 8A, I guess, and this was 4A. So according to me, yeah, this was what it was. It was this was below dotted. I exactly don't remember, honestly. Exactly don't remember the structure, but this has to be S and this has to be R. So likewise was the answer. And there again you had to uh, count the number of C13 signal proton decoupled signals in one structure. Actually that was a reaction. Many of the guys would have been confused, and they would have count the number of carbon signals in the structure given, but there was some typical reaction was happening there. I guess structure was like this. Here was one carbonyl and here was methyl, and they had given one base, exactly don't remember, but let's say, and this kind of a thing was there. So what happened there, the methyl group, extra methyl group is coming here, and here your structure becomes symmetrical, and in just one manner, and you are getting 8 signals over there. So this is what I have for this video. Thanks for watching this video, guys. I'll come up with some some inorganic and physical chemistry solutions in a while. So till then, just stay tuned and enjoy your chemistry. Thanks for being on. Thanks for being on my channel.